Okay, is everyone on page 348?
Yes.
Okay. Today we're going to talk about magnets. I would like for someone to raise their hand and give me one fact that you already know about magnets. It might be something you've read in one of your accelerated reader books. It might be something you read in a RIF book. It might be something you've seen on TV, or something that maybe you learned in the past. Ivy?
I learned that there's North Pole, South Pole. They just stick the two North Poles together, they will repel.
Oh.
And if they're different, like North Pole to South Pole, they will attract.
Okay, so I'm hearing some really big words in there. I'm hearing repel, North Pole, South Pole. All right, Camden?
I learned that it can't attract, like only if it's iron and some different types of metal, like a penny and stuff can attract, like copper and aluminum. It can attract the magnet.
Okay, so it sounds like we have learned some great stuff, maybe from Brain Pop or from some other books. He said that a magnet will only attract iron and other metals. If it's mixed with other stuff, it won't attract the stuff that is not iron or other metals. Adriana?
I learned that magnets have a magnetic field. Whatever is iron, and if it gets close to a magnet, it will just go up to it without touching it.
Okay, so magnetic field. Okay, well, we're going to read some more about that. All right, on the first section it says, what is the invisible force that holds a magnet to a refrigerator? How do magnets work? Do they always attract things? These are some questions that we're going to learn the answers to in our readings today. All right, go ahead and flip the page. Page 350. Sydney, you want to read that page?
Sure. What is a magnet? You may have played with magnets and watched them snap together or push apart. Magnets can also make some objects move or even fly in the air. When you bring two magnets close together, they will either repel or attract each other. To repel is to push away, to attract is to pull together. The force that pushes magnets apart or pulls them together is called magnetic force. A magnet is any object with magnetic force.
Okay, what is a magnet?
Any object.
Destiny, what is a magnet?
A magnet is an object. A magnet is an object that is.
It's right there in your text. Any object with a magnetic force is a magnet. Alright, what is the difference in repel and attract? It said to attract is to what?
Pull together.
Say it, Nayla.
Pull together.
Pull together. Does that sound like a force we've already talked about? What other forces have we talked about?
Push and pull.
Push and pull. Thank you. The force that pushes magnets apart or pulls them together is called a magnetic force. To repel is to what, Jackie?
Push away.
Push away. So that would be like the force push
and
would be
pull.
repel. Attract would be
Pull.
to pull. Thank you, Sydney. Alright, magnetic poles. You want to read that part, Nayla?
Do I read the whole thing?
Yes, go ahead and read that whole section that says magnetic poles.
The parts of a magnet where the magnetic force is the strongest are called the magnetic poles. All known magnets have two poles, a north pole and a south pole. When two magnets are brought together, a north pole and a south pole attract each other. Like poles, north north or south south, repel each other. Magnets that are far apart do not push, pull, or push enough to move each other. The magnetic force between two magnets is weak. When the magnetic force gets stronger as the magnets are brought closer together.
Okay. So, has anyone ever heard the phrase opposites attract? Have you ever heard that, Hazel? Okay. So what would that mean if we're talking about these magnets with north and south ends, and I say opposites attract? What does that mean, Hazel?
It means they would pull together.
Okay, what will pull together?
The north pole and the south pole of the magnet.
Okay. They will pull together, but what if I do south and south? Will they attract?
No, they will repel. They won't let you stick them together. They'll just
They
keep them
repel. Why is that? Because they're not
opposite.
They're not opposites, right? Alright. Refrigerator magnets. Jackie, you want to read that part?
Yeah. Refrigerator magnets are a tiny strip of magnets placed next to each other. The way tiny strips are arranged makes the magnetic force strong on one side and very weak on the other. That is why only one side of the magnet sticks to the refrigerator. By sliding a bar magnet over a refrigerator magnet, you will notice that some areas cool, other areas attract.
Okay. So, the way these tiny strips are arranged makes the magnetic force strong on one side and very weak on the other. That is why only one side of the magnet sticks to the refrigerator. Have you ever thought of that?
Yeah.
Why the other side wouldn't stick? Alright. You are trying to connect the ends of two different bar magnets. They won't connect. How can we fix this? Ivy?
By changing it.
How would we change it? Adrian is helping you out. How would we change it?
Flip it around.
Flip it around where we have
North and south.
right opposite ends. Alright, next page. How do magnets attract? Ivy, you want to read that section?
Most of the magnets you know are permanent magnets. Permanent magnets always have magnetic force. Certain rock contains permanent magnets. Enabling a permanent magnet in a difficult will be permanent magnet. It will have like all of them are made of magnet particles. If paperclip particles are like tiny magnets, normally the chemicals create in different directions. When a permanent magnet is brought near a paperclip, the particles share around the particle line. If you take the permanent magnet away with magnetic particles, you will run again. The paperclip uses its magnetic force.
Okay, thank you, Ivy. That was a lot to read. Alright, let's look at the picture. I want everyone to put their finger on the picture that has the magnets going all different directions. And it says under the picture, metals are made up of tiny magnetic particles. Normally, the particles point in different directions. Okay, so this is all metals are made up of tiny magnetic particles. But when a magnet is not around, they're just kind of crazy. See how they're going all different directions? However, you can see when all the magnetic particles line up, the metal becomes a magnet. Notice that all of the north poles are facing,
The south poles.
they're not facing the south, they're facing, the north is facing one way, and the south is facing another. Why do you think that is like that, Sydney?
Because if you face a north and a north, they would just flip over.
And then the metal probably wouldn't be a
magnet.
right. Okay? What happens within a metal object when it becomes a magnet? What happens to get all those little particles in a line? What happens? They do just what the picture. Yeah, just what you think. They all just spin around and flip in the right direction, right?
Mm-hmm.
That's what happened in the pictures, right? It's not complicated. It's pretty simple. All right. Next page, Adriana, did you want to read that? Magnetic attraction.
Magnetic forces act on some metals, but not others. Magnets can attract some metal objects, such as iron nails. Magnetic attraction is the force that pulls the iron nail toward the magnet. Magnets attract objects made of certain metals, such as iron, nickel, and cobalt. Magnets themselves are actually made from these metals. Magnets cannot attract other metals such as copper or aluminum.
Okay? So, magnets attract objects that are made of certain metals, such as what, Nayla? Look in your text. Magnets attract objects made of certain metals, such as
Iron, nickel, and cobalt.
iron, nickel, and cobalt. So why, in that picture at the bottom of the page, why didn't the magnet pick up the toothpick, Camden?
Because the toothpick doesn't have metal or type of iron in it.
Okay. Why didn't it pick up the crayon? Nayla?
Because it's not made of iron.
Okay. Why didn't it pick up the eraser?
Because it's not made of metal.
Okay.
The kind of metal can pick up.
Can we use a magnet to pick up copper beads?
No,
Why?
because copper is not a kind of iron or a different kind of metal.
Okay. But what does it say in our text?
That copper, like that,
Magnets cannot
attract other metals such as copper and aluminum.
Why do you think it would attract those metals?
Because they don't have iron.
They don't have iron or metal.
Or what? Look in your text. Iron or
Cobalt.
or
Nickel.
nickel.
Iron.
Cobalt, or nickel. They're made of something else, such as copper or aluminum.
Certain metals such as iron, nickel, and
Okay, next page. Hazel, have you read? Okay, do you want to read? You can just read the first two paragraphs and stop there.
To pull like an English merry-go-round, you have to touch them. Magnets can attract or repel objects without touching them.
Oh, pause, wait a second. It says to pull and push a wagon, you have to touch them. All the other forces we've talked about up until now, like push and pull, they all touch, right? If I'm going to push this chair, I have to touch it. I have to touch it and I have to push it. So, how does an object move without touching it? We talked about this a little bit already. Nayla? Remember when we had those skydivers, the pictures of the skydivers? What force?
Gravity.
Gravity. Now, if you remember back on the last page, that magnet, did it touch those things to pick them up? No. What made them pick up?
Gravity.
Not gravity. Gravity doesn't go.
Magnetic.
Magnetic what?
Force.
Magnetic force.
Magnetic force.
So
And
up
the other
until
one-
now, the forces we talked about had to touch. However, magnetic force does not have to touch to move an item, right? Okay, keep reading, Hazel.
How? Every magnet has a magnetic field around it. A magnetic field is the area of magnetic force around a magnet. When one magnet enters the magnetic field of another magnet, it is either attracted or repelled. This can happen even if the magnets are not touching.
Whoa, what does it say, Hazel? Read that last sentence again.
When one magnet enters a magnetic field of another magnet, it is either attracted or repelled.
This can happen. Keep reading.
This can happen even if the magnets are not touching.
What? That's what we just said, right?
Even if it's not
So
touching.
even if it's not touching,
There's a
it can
force.
still
There's
make something move. There's still a force there. Thank you,
There's
Adriana.
a force like gravity. Gravity pulls you down to the ground.